What role did submerged microcontinents play in Arctic tectonics? Imagine tiny pieces of land hidden beneath the ocean's surface, quietly shaping the Earth's crust in the Arctic. These submerged microcontinents are like puzzle pieces that tell us stories about how the polar regions have changed over millions of years. They are fragments of continental crust that broke off from larger landmasses during the breakup of ancient supercontinents. These pieces often stay partially underwater, making them tricky to spot but incredibly important to understanding Arctic geology. In the Arctic, one such microcontinent is located between Greenland and Canada in the Davis Strait area. This tiny land fragment is about 400 kilometers long and between 19 and 24 kilometers thick. It started forming around 118 million years ago when Greenland and Canada began to rift apart. Later, seafloor spreading began about 61 million years ago, creating new oceanic crust. However, the rifting was incomplete, so Greenland remained attached to the North American plate. This partial separation influenced how the region's tectonic boundaries developed. These submerged microcontinents act like barriers that disrupt the usual flow of oceanic crust and influence how seafloor spreading happens. They can change the shape of plate boundaries, creating zones of rifting or faults where plates slide past each other. Their presence also provides clues about past events like continental breakup, subduction, or collision with other landmasses. For example, microcontinents can control where volcanoes form or where sediments accumulate, affecting volcanic activity and crustal thickness. The Arctic's geological history is a mosaic of ocean basins, microcontinents, and fragments of continental crust. Subduction zones south of Arctic Alaska and Chukotka, along with accreted terrains and microcontinents, helped shape the opening of the Arctic Ocean. These processes created a complex network of plate interactions that continue to influence the region today. Studying these submerged microcontinents helps scientists piece together how the Earth's crust has evolved in polar regions. It shows how continental fragments can influence plate movements and the current layout of the Arctic. This knowledge also helps in understanding natural hazards like earthquakes, as faults associated with microcontinents can be sources of seismic activity. In the end, submerged microcontinents are more than just tiny land pieces under the sea. They are key players in the story of Arctic tectonics, guiding how plates move, break apart, and reconnect over tens of millions of years. Their role helps us understand the dynamic nature of Earth's crust in the polar regions and the geological forces that continue to shape our planet.